Mount Vesuvius is radioactive, unusually so in fact, whereas typical spots in central and southern Italy that I measured generated readings of between 6 and 16 counts per second of radiation, the area at Vesuvius's summit generated readings of between 58 and 62 counts per second. And literature agrees with my observation, as Mount Vesuvius is noted as anomalously radioactive. Now, I want to note that while the volcano does produce elevated radioactivity, this radioactivity is still below the lowest levels of radioactivity, which are definitively linked to an increased future cancer risk. In other words, it isn't a health concern in my opinion as a geologist and volcanologist. Also, Vesuvius doesn't produce elevated radioactivity because some hot isotope was once lost on it, as that never happened, or due to far-flung particles from some distant industrial accident involving radioactive products, as that also never happened. Instead, the volcano itself and many of its eruptive products are the source of this elevated radioactivity. And this level of elevated radioactivity is not a typical phenomenon at most world volcanoes. Instead, what is occurring at Vesuvius is fairly unique. So, why exactly is Vesuvius somewhat radioactive? Well, there are a number of elements that can be clustered in sufficient quantities in the crust to generate elevated radioactivity in an area. In most cases, the culprits come down to specific isotopes of uranium, thorium, and/or potassium, if you also include their associated decay chains. In the case of Vesuvius, all three of these play a factor, but more than 95% of measured radioactivity originates from uranium and thorium if you include their respective decay chains, primarily because those decay chains at some point include an isotope of radon. Typically, the Earth's crust contains an average of 2.4 parts per million of uranium and 7.8 parts per million of thorium. In contrast, Vesuvius's lavas contain an average of 6 parts per million of uranium and 19 parts per million of thorium. So, Vesuvius's eruptive products largely contain elevated concentrations of uranium and thorium. But why? The answer relates to its unique geologic setting. Mount Vesuvius sits in a location where, beneath it in the mantle, a segment of the African plate is subducting underneath the Eurasian plate. Normally, partial melting would occur at a specific depth, and this material would subsequently rise to form magma, which would then form volcanoes, but at Vesuvius it's a bit different. At some point, a segment of the subducting African plate snapped off, creating a gap in between the two segments. This subsequently caused hotter material in the mantle to rise upwards through this gap, causing partial melting to occur at a somewhat unusual point. Such heat causes the release of volatiles, largely water, from the subducted slab, causing it to rise. This then lowers the temperature needed for partial melting to begin, and this creates magma. However, liquids are not the only thing that can rise during this process. Often, so-called incompatible elements can rise with them, enriching resulting magmas with these elements. And both uranium and thorium are considered to be incompatible elements. Thus, the only logical conclusion is that a portion of the subducted slab feeding magma generation of Vesuvius either contains some form of uranium and thorium deposit, or the slab is more broadly enriched in these two elements. Given the geologic setting that the subducted oceanic crust originated from, the latter seems far more likely. One linked scientific paper agrees with me, suggesting that uranium and thorium-enriched subducted marls are the culprit of these elevated element concentrations at Vesuvius. As to why radioactivity at Vesuvius is seemingly highest at its summit when compared to lower elevations, while this is highly speculative, I suggest the fumarolic degassing of some minor quantities of radon-222 originating from the uranium-238 decay chain are the most likely culprit. It just so happens that the greatest cluster of fumaroles at Mount Vesuvius happen to be within its summit crater. I hope that you found this video interesting. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.